Welcome to vertical asymptotes. So the idea here is we say that a graph has a vertical asymptote or a function has a vertical asymptote at x equals c if the left and right limits are either positive or negative infinity. They do not need to match. Essentially what is happening is the function will get closer and closer and closer to the line x equals c, the vertical line x equals c, but will never cross. So essentially the graph will get closer and closer to the vertical line x equals c, but never cross. So if we just draw a little graph off to the side here, and we can put in our vertical asymptote here. And then when we draw a graph, it can do whatever it wants before, and then at that line it gets closer and closer and closer, heads off to either positive or negative infinity. And from the other side, same thing, heads off to either positive or negative infinity as we get into that x value. So let's consider the function f of x equals x minus 3 over x squared minus 1. And our job is to find the vertical asymptotes of the function. So what we are looking for here is we first look for where the denominator equals 0. And then check that the denominator goes to 0 faster than the numerator. So if we were to factor our denominator, x squared minus 1 factors as x plus 1 times x minus 1. That numerator is already factored, it is simply x minus 3. So the denominator equals 0 when x plus 1 times x minus 1 equals 0, which could happen either when x plus 1 equals 0 or x minus 1 equals 0. And so we get that x could be negative 1 or positive 1. So at both of these values, the denominator equals 0. Then we just need to check that the numerator is not also going to 0. So if we look at as x goes to negative 1, we have our fraction x minus 3 over x plus 1, x minus 1. The bottom is going to go to 0, and the top will go to negative 4. So this is going to go to either positive or negative infinity, right? To check specifically, we would need to look at which side or which way we're coming from. So on the bottom, As we go to -1, it would depend on which side we're coming from, whether we would be looking at a positive or a negative. But we do know we'll be going to one of those infinities. As x goes to +1, x minus 3 over x plus 1, x minus 1. The denominator will go to 0. The numerator will go to -2. And this is going to be either towards positive or negative infinity, again, depending on from which side we are approaching 0. So both of these will be vertical asymptotes. So our vertical asymptotes will be at the lines x equals 1 and x equals -1. Now let's go ahead and consider the function g of x equals x plus 2 over x squared minus x minus 6. Once again, we will factor. So that numerator is x plus 2. The denominator, x squared minus x minus 6, factors as x minus 3 times x plus 2. So the denominator equals 0 occurs when x is either 3 or -2. But you'll notice that that numerator also becomes 0 at this point. Right? So if we look at x equals 3, so as x goes to 3, we have x plus 2 over x minus 3, x plus 2. The denominator will go to 0. The numerator will go to 5. And so we get either a positive or negative infinity. So we do have a vertical asymptote at x equals 3. At x, as x goes to -2, we have an x plus 2 over x minus 3 times x plus 2. Both the top and the bottom will go to 0. And who knows what happens with that, right? But as we saw when we did limits earlier, this is the same, or is almost the same as 1 over x minus 3. We can simply cancel out our x plus 2's as long as x does not equal to itself, or is negative to itself. And so if we let that x go to -2, we have 1 over x minus 3 will go to 1 over -5. And so we don't go to positive or negative infinity. We do not have an asymptote there. So we have no asymptote here. It's a hole in the graph. And at x equals 3, so there's no asymptote at x equals -2. But we do have a vertical asymptote at x equals 3. So you have to do more than just find where the denominator equals 0. You also need to check that the numerator won't overrule that denominator. So we'll cancel out the shared factors between the numerator and the denominator, simplify our function, and we can figure out if there's an asymptote or not.